All right, today lesson 10A. Our focus the last few days has been with unit rates. Today we go into full depth of unit rates and graphs. And so all of the things that we've been talking about before today come into play today. And so let me just do a quick review of that. Look, if we know that the constant, and I'm just going to write constant of proportionality is, I don't know, k equals 1/2, then the unit rates might be something like 1/2 of a mile per hour, depending on whatever the context of the problem is. The equation might be something like y equals 1/2 x. I don't know why I wrote k when I said x. And the ordered pair where the unit rate is found would be at like 1, 1/2. Today, we're kind of just putting all of these things together. And if it hasn't been clear to you before today that the constant is found in all four of those, it needs to be clear to you. Yes?
Can I get a pencil?
Go ahead. You don't have to ask me. Okay? So I just wanted to reiterate all of that stuff, and that's kind of what I'm talking about right there. So let's go to number 1. So number 1 says, is this a proportional relationship? How do you know? That should be obvious to you. Go ahead and answer that question in your notes, please. Is that proportional, yes or no? How do you know? It's two things. Two things have to happen, right? What's one of them? Yeah.
Go through the origin.
Well, it's something that goes through the origin. What goes through the origin? It's a line, right? So in order for us to have a proportional relationship with a graph, we have to have a line, and it has to go through the origin. Okay? That part you already know with regards to a graph. This is the new part. How in the world do you find the constant of proportionality from a graph? Well, the first thing we have to do is we have to take at least one ordered pair that is provided to us, and that ordered pair is provided to us. By the way, that is 16, 12, and this is where you should start writing in your packet. Remember, anytime we have an ordered pair, the first number in an ordered pair is x, and the second number is a y. So what the graph is telling us with regards to that ordered pair is that there are 12 y's for every 16 x's. Now, why did I write the y's first and the x's second? Because that's how we work backwards in a table when we're trying to find. Yeah, so the question there was, could we have used this ordered pair instead? Because that's a perfect one. And yeah, we could have. We could have used that one instead. In fact, I'll bring that back up after I show you how to find the constant of proportionality.
Would that be simplifying?
Well, it certainly would be simpler than the other one, but it still, even then, could be simplified.
Oh,
Okay? So when we're working backwards in a table, remember we always take that value and divide it by that value right there. In other words, we're taking the y number and we're dividing it by the x number. Well, that's what we do in terms of a graph. So between the 16 and the 12, which one is the y number? That's not a trick question. Which one is the y number?
12.
It's the 12. Which one is the x number?
16.
It's 16. Look, I just told you that right here. And so 12 over 16 is the constant of proportionality. It's just not simplified yet. So the question was, well, what about this order pair? Well, this order pair is 8, 6. We could have also used that one instead, but we still have a situation that is not simplified. So we have 6 over 8. Regardless of that, can you simplify either 6 over 8 or 12 over 16? Okay, so this is 3/4. This simplifies to 3/4. That's why last week we were reviewing from an earlier grade how to reduce a fraction. So that means that the constant of proportionality is 3/4. Okay? So anytime we have an ordered pair on a graph, we take y over x, simplify that fraction. Here's what's going to happen as soon as I have you guys try a problem on your own. Some of you are not even going to pay attention to which number is y and which one is x. And if you do that, you're going to, in the homework, have to redo problems over and over and over again. It is y over x, because we're using the same strategy that we do when we go backwards in a table when we can't see the constant of proportionality. Okay? All right, so, and that's basically everything that I just talked about right there. And if we wanted to go the decimal route, we could, but in my opinion, it's easier to just go with the fraction because all you're doing is reducing. All right, let's go to part C, which is the unit rates. Now, I tried to make sure everybody understood yesterday that if the constant of proportionality is 3/4, 3/4 is part of the unit rates. So it's going to be 3/4 something per something. What per what? And we did have a problem like this yesterday with a table. Yeah. There you go. So we can sort of abbreviate that a little bit. It's 3/4 y per x. Because it's always output per input. That's from yesterday. Or in this case, y per x. If, and I know it doesn't say that, but if this was miles, if the y-axis was represented with miles and the x-axis was represented with hours, then it would be 3/4 of a mile per hour. Output per input. Okay? And then we have the equation. I think everybody can figure out the equation. Go ahead and figure out the equation. And that should take all of about 5 seconds. What is the equation? Tell me, please.
Y equals 3/4 x.
Very good. We can look on our axes. We're using y and x, so it is y equals 3/4 x or y equals 0.75 x. And then the last part is what point on the graph represents the unit rate? Well, that's why I started today with saying if k is 1/2, the constant of proportionality is 1/2, the unit rate is 1/2 y per x, the equation is y equals 1/2 x, and the ordered pair that's on the graph that represents the unit rate is 1 comma 1/2. Because remember, the unit rates on the graph is always the point 1 comma k. And since k is 3/4 in this one, it is 1 comma 3/4. So let me just quickly in this one go through all these parts again. We found out that the constant of proportionality was 3/4, so k equals 3/4. The unit rate was 3/4 y per x. The equation is y equals 3/4 x. The unit rate on the graph is at 1 comma 3/4. That summarizes all of the different things that we've been working on the last week and a half or so. Okay? All right, go ahead and turn the page and do all parts of number 2. So, is this a proportional relationship, yes or no?
Yes.
Clearly it is, because once again we have a line through the origin. All right, now I'm going to do all parts on this screen right here. Remember, and I know we've got D and T here, but I'm going to just stick with the X and Y. To find the constant of proportionality from an ordered pair, it's always Y over X. Once again, we're using the same logic that we used when we were working backwards in a table. Y is 50. X is 40. When you simplify that, that is 5/4. There's no need to convert it to a mixed number. There's no need to convert that to a decimal. It's just 5/4. So the constant, and I'm going to do all of it on this screen, is k equals 5/4. That's the constant of proportionality. The unit rates. definitely has 5/4 in it. 5/4 what per what? Any ideas? You have to look at the context. This time we have labels on the output axes and the input axes. Yes?
Meters per second.
There we go. It is 5/4 meters per second. I'm abbreviating because I'm kind of out of room there because the output axes, meters represent that, seconds represents the input axes. Okay? Next, I think you were asked for was the equation. This time we have to pay attention to the fact that we do have different variables. What's the equation? Yep.
I have a question.
Yep.
So can we put it as 1 and 1/4?
I would rather you just leave it as 5/4, but you could. You could.
I can answer that.
Okay, go ahead.
D equals 5/4 D.
And hopefully, right now, all of you understand the hardest part is finding the constant of proportionality. Because once you have that, everything else should be pretty easy. And I think was the last one the point on the graph?
Yes.
Yeah? Okay. So can somebody please tell me what the point on the graph would be? I just talked about it in number 1. Yes.
1,5/4.
There you go. 1,5/4. And once again, the hardest part of this is finding the constant of proportionality right here. Because 5/4 is there, 5/4 is there, 5/4 is there, 5/4 is there. Okay? All right, let's go ahead and turn the page. Let's take a look at number 3. I have to get to number 3 because I've already done all these parts. All right. So, the order pair that is plotted there for us is 4, 10. Now we have a slightly different question here. The question is, what does the plotted ordered pair represent? Well, 4 is right here, and that represents the number of seagulls. So 4 seagulls for every, the 10 is pounds of garbage. So 4 seagulls for every 10 pounds, and LBS is the abbreviation for pounds of garbage. The 4, since the input axes, or the x-axis, or in this case the n-axis, is number of seagulls. So that's 4 seagulls for every 10 pounds of garbage. Everybody okay with that? Yes? Do you understand why it's not 4 pounds of garbage for every 10 seagulls?
Yeah.
Okay, all right. So that's part A. And you could word it differently if you wanted to, but as long as it means the same thing. Okay? All right, part B. Everybody try part B. Okay, so in order to do this, you got to figure out what the constant of proportionality is first. What is the constant of proportionality? What is it? Let's leave it as a fraction. 2.5 is what it is as a decimal. What was it as a fraction?
2 and 5, 10.
What's that? How'd you get 2.5?
Dividing 10 to 4.
Oh, you went 10 divided by 4 because this ordered pair right here is 4, 10, right? And you went y over x, which is 10 over 4. What I'm saying is I think it's faster and easier to just leave it like that. However, 10 divided by 4 or 5 divided by 2 is 2.5. So either one are technically fine, okay? But that's not how many pounds of garbage there are for 1 seagull. There are 5/2 pounds per seagull.
That'd be 1 and
Yeah, or 2.5 pounds per seagull. That's just a different way of asking for the unit rate, because that's what a unit rate is. How much of something for one of something else. All right, so you now should be able to do part C and part D. Everybody do part C and part D. Okay, so in order to figure out what point you have to plot, you have to figure out what the point is. What is the point?
1,5/2.
1 comma 5 over 2. Thank you. That's exactly what it is, because it's 1 comma k, and we already figured out the k was 5 halves, or 2.5. So it would be 1 comma 5 halves, or 1 comma 2.5. Now, I did actually ask you to plot it. That means actually put it on the graph. And so 1 comma 2.5 would be right there. Plot it, please. That's where 1 comma 2.5 or 1 comma 5 halves is on the graph. What's part D? Is it find the equation? Yes or no?
Yeah.
Okay, good. And you go ahead and quickly do the equation. All right, so part D, what'd you get for the equation?
Y equals 5.
Okay, but we're not using y this time.
Oh.
P equals 5 over 2. And
There you go. Very good. Okay? Either p equals 5 halves in or p equals 2.5 in. All right, go ahead and turn the page and do all parts to number 4 quickly. The ordered pair 12 comma 5. 12 is an x value or a t value in this case, and 5 is a y value. So that is referring to seconds. This is referring to gallons. So no matter how you phrased it, you should have said something like 12 seconds for every 5 gallons. Or something like that. Okay? I put after 12 seconds for 5 gallons of water in the bucket, since that's what the problem is talking about. But something like 12 for every 12 seconds, 5 gallons, something like that. Okay? Now, here's the other part that some of you are messing up on. This order pair is 12 comma 5. This is an x value, that is a y value. So for the 4th time in a row, to find the constant of proportionality, it is y over x. It is not x over y. It is always y divided by x. In this problem, what is y? What is x? Is that reduced? Yes, that's the constant of proportionality. Now, I know I didn't ask for it in this one, but that's what it is. Part B says, how many gallons of water were in the bucket after 1 second? That's like asking for how many gallons per second. Well, yes, there are 5/12 gallons, I'm going to abbreviate, per second. That's part B. Part C, we're talking about G and T as far as your output and input variables. So G equals 5/12 T. I didn't ask this, but where's the unit rate on the graph?
Oh. 1
Where'd you get 12/5 from?
um,
Yes,
1 comma 5/12.
it would be at 1 comma 5/12. I didn't ask for that one, but if I did, that's where the unit rate is on the graph, at 1 comma 5/12. So once again, 3 or 4 of you are just going the left number divided by the right number. That's not what I'm saying. It's y over x. That's how we work backwards in a table. Let's go to the last idea for today, number 5. So sometimes we're given a graph where there are no visible points. However, we're going to have to locate at least one perfect ordered pair. And by the way, in this one, all we're asked to find is the equation. So could somebody locate at least one perfect ordered pair for us? Yeah.
520.
520. Well, 5 comma 20 is right here. 5 comma 20 would be way up here somewhere.
20 comma 5.
Yeah, you mean 20 comma 5, right? Okay. All right, so 20 comma 5 is
40 over
right there. There is another one, right? What was it?
40
Yeah, 40 comma 10. It doesn't matter which one of those you use. It does not matter. So you could use 20 comma 5, or you could use 40 comma 10. But regardless of that, go ahead and find the equation, please. All right, so I'm going to do two things wrong on purpose. So please let me know when you see what I've done wrong. So the constant of proportionality is 4, because 40 divided by 10 is 4, or 40 divided by 10 is 4, or 20 divided by 5 is 4. Why is nobody stopping me?
What?
I said I was going to make two mistakes for a reason, on purpose. You're supposed to stop me. K is not 4. What is it? It's what?
It's 1/4.
It's 1/4. Because y divided by x is 10 divided by 40, which is 1/4, or 5 divided by 20 is 1/4. So there was mistake number 1. Here's mistake number 2. Please let me know when you figure out what that mistake is. We're asked to find the equation, so it would be y equals 1/4 x.
No.
What is it?
D equals 1/4 M.
Yeah. And so the reason why I'm doing this is because these are the common mistakes that some of you are going to make as you're going through this. There's D. There's M. So it should be D equals 1/4 M. All right, one more problem. Go ahead and turn the page and do number 6, and then we are finished for the day. All right, so our perfect order pair is right there at 20 comma 6. That's what we need in order to figure out what the equation is. So what is the equation? Tell me, please. Y equals 3/10 x. Very good. Because 6 divided by 20, or 6 over 20, reduces down to 3/10. And we are using y and x in this problem, so it is y equals 3/10 x.